Hello, welcome to Save the Frogs Africa meeting. I am Dr. Kerry Kriger, founder of Save the Frogs, and I'm happy to be here. We have Dr. Ed Basham, originally from the UK, did his Ph.D. at University of Florida, doing his postdoc at UT, University of Texas, Austin, and has tons of experience looking for frogs up in the high canopy in Gabon, Madagascar, and some other places, which he's going to tell us about. So I'm going to go ahead and turn it over to you, Ed. Everybody out there, thanks for being here. If you have any questions, go ahead, chat them in. And when Ed finishes up, we will have a Q&A. You can also ask your questions by unmuting yourself after the presentation. All right, welcome, Ed.
Cheers. Yeah, it was great to present some of my research. I'll primarily be talking about what I was up to in Gabon last year, but linking that across to some of my PhD research in Panama. Okay, do you all see that? Okay, great. Okay, so yeah, my topic is mysterious frogs in the treetops of Gabon. As Kerry said, I'm currently a postdoc at the University of Texas, and a brief bit of background. I finished my PhD at Florida in 2021, and I was wondering what on earth I was going to do with my life, and thought, I just really love climbing trees and finding frogs still. So if I get a postdoc, I might be able to keep doing that. And so I applied to the UT, and I got runner-up. So I was really, really close, and it took a lot of effort to make that application. I thought, oh, so close. And so I decided the next year to fundraise and self-fund a independent expedition to Gabon so that I could use that preliminary data on my next application. And that's what I did, and I got the job, so it worked. Anyway, so this is what I actually did at that time. And I will go through some sort of like background of my subject. This is the kind of thing that I see on a daily or on a nightly survey, climbing up into the canopy. So I'm really interested in vertical stratification. So that broad sort of term, I'm interested in that vertical gradient, whatever happens from ground to canopy in forests. And that can be a layering. So we often hear things like understory, mid-story, canopy. Those are pretty distinct categories, but also it is realistically a continuous change of conditions of biodiversity from ground to canopy. Looking at myself, here we go. So in forests, it's pretty obvious that we have distinct differences, especially in climate. So we have the temperature and humidity changes, and we have wind speed differences, solar radiation, anything, you name it, it changes across that gradient. And that's due to the buffering of the layers of vegetation above. Obviously have differences in structure. So different actual structures like trunks into branches or leaf litter into leaves, and differences in the density of foliage occurring across that gradient. And then all of these abiotic factors, and then also the biotic factors, influence the distribution of biodiversity across that gradient. And that's really what I'm interested in. And we know that this biodiversity is unevenly distributed between the ground and the canopy. We can just look outside, we look at a tree, and we see different kinds of animals occupying different layers, doing different kinds of things. So it's obvious to us that those gradients exist. And some of the most important parts of that is this climate gradient, cool and moist on the ground, hot and dry in the canopy. And then this difference in habitat availability and habitat structure, it all changes the abilities of different animals to access those different layers. And obviously we see different animals and they have different abilities, morphologies that allow them to utilize these different layers as well. I'm super interested in amphibians, obviously, and specifically frogs. This is a cool tree frog that I found in Gabon. I love to Bellis. There are around 8,000 species worldwide of amphibians, around 6,000 species of frogs estimated. And those are what I'm going to be focused on. As we all know, they're highly threatened. They have their highest abundance and richness in the tropics, and particularly rainforests. That's my core component for this talk, is rainforests, what I'm interested in. They're incredibly dense with biodiversity, especially frogs. And frogs have this incredible diversity of morphologies, reproductive modes, physiologies, and different habitat use. So they've adapted to loads of different conditions. So reproductive mode, for example, could be defined up to 50 different reproductive modes at this point, and we keep adding new ones. So we have, let's say, they make a foam nest and the tadpoles develop within the nest, or we have frogs that lay their eggs on leaves and then the tadpoles drop into the water. We have ones that use tree holes to breed, etc. So lots of different varieties and different behaviors. And frogs are obviously this amazing model organism for studying distributions across climate gradients and environmental gradients generally, because they're so sensitive. They have this permeable skin, which regulates their gas exchange and water exchange, and they're ectothermic, so they really rely on that environmental temperature to get them going. Plus, for me, there's very, very few data on vertical distributions of amphibians. There's really hardly anyone climbing trees to find these frogs in rigorous surveys, which is a great opportunity for me to break some new ground on this subject. Lots of cool questions we can ask about arboreal frogs, such as why do they want to actually climb up, and what is it that enables them to survive in the canopy? And as a community, how do they stratify in vertical space? I won't necessarily be answering all of these questions, but they are certainly interesting. So when we look at different frogs, there's some pretty obvious differences that we see when we have like, oh, a canopy frog, it's got big toes maybe, or has a particular morphology. Ground frogs, sometimes they have these big legs that are good for hopping. But what about Kermit? We'll come back to him later. So what was my actual research in Gabon about? Gabon is a country in Central Africa. It's the only place where Central African rainforest actually meets the ocean, the Atlantic. It's an amazing country where they have almost about 90% forest cover. Most of this is tropical rainforest. I mean, it's right on the equator. And this is contiguous with the amazing rainforest of the Congo Basin. So it is, when I study a forest in Gabon, it's very much applicable across Central Africa because those conditions are reasonably similar. There's no huge mountain ranges, and a lot of the species have wide distributions across this area. It's a country of 2 million people, which compared to the UK, which is about the same size in area-wise, which has 70 million people, it tells you a lot. It's low density, and most of those people are actually in the main city as well. So it's a big open country of forests. Massive biodiversity of all different taxa, and very understudied. Like I was saying about just generally low study for canopy amphibians in the world, well, there's been none done at all in Central Africa. So this is really, really a gap in our knowledge. This was my field crew. So I was in a tiny village called Baposo, which is really in the middle of nowhere. So you can see this like gold star here. It's on the way to the border town Malinga, which crosses over to the Republic of Congo. And there's no electricity and there's no real running water. You just use rainwater and all this kind of thing. Very rustic, but I had a great time there, and the food was great, so I had no complaints. So really my objectives were to look at the core concepts of community ecology, basics, abundance, how many frogs, richness, what kinds of frogs, and composition, sort of like what's the actual community looking like in terms of richness. And then a secondary was to analyze the relationship between some morphological traits, so the actual size and shape of the different frogs, and the reproductive modes with vertical height. So where are the frogs, how, and maybe why? The why we can sort of just like stipulate and make hypotheses. This is a reasonably poor photo of my study village, but it was a beautiful place. My basic methodology, and this is one that I've repeated across multiple sites now, so in Panama, Madagascar, and Costa Rica and Gabon. Lots of climbing. So I would conduct nocturnal vertical transects. I would try and get as high as I could, but generally this was as much as about 30 meters. because above that, it just gets really difficult to actually find a good place to put your line, and the trees don't go that high often. So I would set up my ropes in the day, have a big catapult, fires a lead weight over the branch with a thin line attached. When you've got it over a good branch, you use that thin line to pull your actual rope up, and then you've got an anchor point in the canopy, and then you can use a harness and systems to get up into the tree. And I'd come and do that at night. I also did a paired ground survey as well, just to sort of supplement what I was doing in the trees, but I won't really be presenting on that today. So I took 1 hour was my survey time, and I would try and do 2 trees per day. So I'd go to the, setting up and getting everything ready takes a long time. You get back to the tree at night, and then you've got to climb it for an hour. It takes ages to set everything up, but that was generally what I was aiming for. Chose loads of different tree species and different locations around, which I'll show you the map, to really represent a variety of habitat types. So different size classes and different bark types, different epiphyte loads on the branches, all these kind of things to get a better picture of the entire forest. I'd collect amphibian trait data, which I'll talk about, and climate data as well. So this is the kind of thing that I was up to, swinging around, trying to find those little microhabitats and epiphytes, looking around and trying to find frogs. Now, this is a picture from Panama, but just to evidence kind of the arboreal habitat that I'm really interested in, which is good for frogs, is this is a branch at 25 meters up, so that's like 75 feet. And it's got this huge aggregation of different epiphytes on it. So this would look different in Gabon, but it's similar ideas in that you get these aggregations of leaf litter, different plants, orchids, mosses, and these provide those amazing shelters for frogs to hide in, and they also provide the prey species, all those little mites and ants and beetles, everything. That's what allows these frogs to actually live up in the canopy. This is my ugly mug and a housing for a temperature logger. So I have a temperature and humidity logger inside that, and this is what I use to protect them from direct sunlight and from rain. I have one in the canopy, one in the understory, and then I have one in the ground, which is just the temperature. And my groundy Devon at the back. This was the distribution of trees in my little study site. So just a couple of kilometers away from the village. It really, I'm sort of limited on how far you can actually walk and it be sustainable to get into the forest for the distances. But the elevation was relatively similar, so 650 to 750 meters in elevation. But we tried to get a range of, in the valley, up on the slope, up on the ridge, to try and get different environments. So I did 74 tree surveys. I caught 141 frogs on those surveys. And that was of 20 different species. So a really good diversity of genera and different families. However, this doesn't really reflect a full community. So when I include my ground surveys, where it's a lot easier to catch frogs, you can cover a lot more distance. I got 550 individuals and upwards of 50 species just at this one site, just at this one site. So a really huge diversity. And some of those are yet to be identified. So in terms of the way I was accumulating species as I added new sites, I can see that basically if I kept doing, I need to keep doing lots more vertical surveys because there's a lot more on the ground that I'm not finding. Basically, there's just a lot more ground frogs that sometimes you miss. And so I need to go back and do some more surveying. But at the same time, we did pretty well, I think. So where actually are all the frogs? Now, this is a density plot. So it's really just what are the density of frogs across vertical height. We have lots and lots of frogs on or near the ground, declining really rapidly into the understory, where you're climbing up to 5 meters and you're not catching that many frogs, but there's a reasonable amount in that understory zone. And then upwards of 10 meters, hardly any frogs really occurring. Every now and again you'd find one. So a lot less up into the canopy. In terms of richness and composition, we have all of my species here color coded, and then the colors are mapped to between the maximum height they were found and the minimum height they were found. So this is the distribution of the ranges of all of those species that I found. So we've got this amazing kind of aggregation of species in the understory, particularly this Leptopellis genus and the Hyperoleus and Afrixalis genus. So they're these reed frogs and kind of swamp breeding frogs that are very arboreal, and they stay around in the understory. But also I did find quite a few quite up high. Nonetheless, we have this general decline of richness up into the canopy, which kind of matches our, less frogs basically occurring up into the canopy. But the abundance is certainly a lot steeper in its decline. I think that when we saw that I didn't catch all of the frogs that were available in the landscape, a lot of those, I think, are these ground frogs that we're missing. So if I did a lot more sampling, I think we'd see this bar here increase quite a lot. And that's my expectation if we did a lot more sampling. So if we think about why, this is data from a tropical forest in India, but it's a really typical pattern of the distribution of foliage across that vertical gradient. So we have this decline in foliage essentially up into the canopy with some kind of small peak where we have the crowns of trees. Again, a different example from forest in New Guinea. And it really speaks to the distribution of available habitat, essentially. It's, where can a frog actually be? It's the available space that they have. So I think this kind of habitat distribution is going to be quite important in defining the abundance and richness distribution of these frogs. I need to go back and collect this data, essentially, so I can confirm it from my site, or at least confirm the correlation. But also, I think climate is going to be important as well. So this is the climate data that I collected. I have here temperature on the left and I have humidity on the right. As I said, I've got my soil, understory, and canopy loggers and the 24-hour day. So we've got the understory and the canopy get really hot in the daytime, so that midday sun, and especially in the canopy, we get those hotter temperatures. It's what we can imagine. Exposed to direct sunlight gets a lot hotter. Equally, in the day, it gets a lot drier. So we have these low humidities in the middle of the day. I think it's really interesting, though, that the differences between the very top of the tree and the understory just above the ground are basically only because of those midday temperatures, midday events. At night, they're basically exactly the same. So if those frogs that are occurring in the high canopy can find a micro habitat or refugia to escape those kind of temperatures, then essentially they're living in a similar climate environment as the ones near the ground. And the soil is very buffered. So this is actually under the soil. So we buried it 10 centimeters down. And so it really doesn't change much. So switching gears slightly to Panama. So I said I did the same method there, and I climbed lots of trees and found frogs in the same method, and I'm just going to link that to what we see here. However, in Panama, what I did was sample a bunch of trees across the landscape, but I also did it from the dry season and separately in the wet season. So in Gabon, I was sampling in the wet season only. Here, I was sampling dry and wet. Now, what I see, so same type of diagram, different species. Here, I did have lots of sampling. So I did a lot more sampling, and we do have this kind of big bar of ground species occurring just at 0 meters. Same in the dry. Big difference here being in the dry season, we have way less species occurring up into the trees. So we have this essentially a descent, a decline in vertical complexity in the dry season, and a descent of many species literally climbing down towards the ground, which is buffered against those extremes and maintains its moisture and is cooler. And we also, so just to evidence those abundance shifts in Panama, I did essentially a resampling technique, but the takeaway message is that the community at large moved down by an average of 5 meters. So that was an average of all the species that I found in Panama. It moved down by about 5 meters on average, the community did, into the dry season. But this is obviously a big mix of all the different individual relationships of different species. So this extremely arboreal Pristomantes crentus, it declined its range by about 13 meters on average. So it often was quite high up into the trees in the dry season, come down by an average of 13 meters. Then we even have species like this dendrobatid, Andinobatis fulguritus, which actually declined its range by 26 meters. So I only found them right up into the canopy in the wet season, in the bromeliad gardens, essentially in the canopy. And in the dry season, they only occurred on the ground, leaf litter underneath the roots of the same trees that they were inhabiting. So we can see that there are obviously these really specific, species-specific patterns, and those are going to differ depending on their traits, morphologies, reproductive modes, etc. Now, I don't have the data to do that in Gabon, but I think it's really interesting that we see that. So this is one of those cool poison frogs that I was looking at. And like I said, I could see actually they have a unique ventral pattern underneath, which I think we just saw actually. Oh, there it is. So this one I called Captain Hook, and they all have a perfectly unique pattern. So I would resurvey the same trees, find the same frogs, and I could tell where they were, and I resampled across 3 years and 5 seasons, so dry season, wet season, dry season, wet season. And they were living on the same trees basically the whole time, down to the ground, up into the canopy, down to the ground, up into the canopy, same tree. But let's get back to our comparison with Gabon. So we have our wet and our dry season, and we can just make a sort of visual comparison of what we saw in Gabon. So importantly, we had almost double the surveys in Panama for the wet season, quite a lot for the dry season, still more than the 74 surveys I've done in Gabon. So I think that we will get that a lot more species on the ground if we do more sampling. But we've got this general decline up into the canopy across Panama and Gabon. Although we do see still quite a few species right up into the canopy in Panama, less so in Gabon. Again, preliminary data. In terms of our abundance distributions, so we've already seen this figure from Gabon, where we have very few occurring up into the canopy. In Panama, it looks slightly different. So we have this, essentially this space here is telling us that we have this maintained abundance all the way up into the canopy, and less of a less steep decline up into the understory. So we've got a lot more frogs actually occurring into the trees in Panama, and quite consistently. And so, you know, just anecdotally, I would find tons of frogs up into the trees in Panama, whereas in Gabon, I was up there 15 meters and thinking, oh, this, you know, after 2 weeks, I was like, oh, I'm not finding anything up here. There's hardly anything. So it was a bit disappointing actually in Gabon, but just a different habitat, different landscape. And there are some reasons that we can think about as to why. I think that the types of epiphytes that I was finding are very important here. So bromeliads specifically, in Panama, lots of bromeliads, and in the neotropics, lots of bromeliads. There's none in the Afrotropics, apart from one species that occurs on a mountain in Guinea. Now, these are, as we probably all know, really, really good microhabitats for frogs. They provide the water, they live in, they're up in the canopy, these little microhabitat refugia. And there's actually 99 species that are specifically adapted to raising their larvae within bromeliads. So I think that as there's no bromeliads and there's actually no real equivalent type of epiphyte in the forests of Central Africa, there are lots of epiphytes, but none that do this kind of job. I think that this is going to be quite important in limiting that canopy niche kind of environment that frogs could exploit. And maybe this is a reason why we're not seeing quite so many sort of species right up there and abundance of frogs right up into the canopy in this forest. Again, I need to go back and climb more trees in different areas in Central Africa to confirm that kind of hypothesis, but I think it's important. So in terms of our morphology and reproductive modes, I measured a lot of things in these frogs. So mass, the length of the frog, the length of its tibia, toe disc width, mouth width, and then I also did the ratios between each of those. So I have, say, tibia ratioed with the toe disc. And also reproductive mode, which according to Bordick and Blackburn, I've distilled down essentially into generalized categories, which were 5 categories, which are the following. So this lovely frog, Hyperoleus mosaicus, is a tree hole breeder. So it's a phytothelm breeder, lays its eggs above a tree hole, and those fall into the water and develop aquatically. We have arboreal laying, but aquatic developing. So they lay their eggs on leaves or surfaces, and then tadpoles drop into water. This lovely Cardiodlossa lays its eggs on the ground, which then get inundated by rain and washed into some kind of water body where they then develop as tadpoles. And then toads, this lovely Sclerophorus, which I don't know what kind of species it is yet, lays its eggs actually in the water, and then those tadpoles develop in the water. And then we have the direct developing frogs like this Arthroleptus. So they can lay their eggs on any kind of damp substrate, and then the tadpoles within the egg can develop all the way into a froglet and come out already as a frog. So they actually never need to go into the water. And that's, I think, super important adaptation for, they're essentially liberated from the ground. Some species, if they don't need to ever come down to the water, that could enable them to explore the canopy. But that's not what we saw here. We'll see that. So what did I do for the actual analysis? I looked at essentially each trait, the mean value for each species or each trait against the mean height that I found those species. I did linear models, and I duplicated those models with a polynomial function because I wanted to make sure that, well, basically things might not be perfectly linear, it might be curved. Compared by AIC, what did I find? The best models were the ratio between the length of the frog, that's SVL, and toe disc width. So essentially, frogs which have shorter bodies and wider toes, more likely to occur higher in the canopy. I suppose we probably all expected that, but it's nice to actually see it in statistical language. So this is actually what that relationship is. So we've got height on the left, and this is scaled and with SVL and toe. Declining, and these are the kind of ground frogs that we see, very thin toes, longer bodies relatively compared to our tree frogs with big wide toes. In terms of our reproductive mode, we had some obvious patterns, but because I don't have that many species that I could actually do this analysis with, nothing was actually statistically significant, and I'd need to get some more species for this. But the interesting thing is that all of the direct developing frogs that I found with that particular genus, Arthroleptus, and they're all ground frogs, completely limited to the ground. And this was in stark contrast to the ones that I found in Panama. So, but just briefly, it's quite obvious that if you're an arboreal laying frog, it's probably more likely that you'll be a canopy frog and occur higher up into the canopy. So that's the kind of relationship that we're seeing there. So this awesome Pristomantes crentis that I found in Panama, which we saw has got this very high canopy distribution, it doesn't need water anymore. It just needs humidity. And I actually found some of these guys with egg masses under just bits of damp moss right high up in the canopy. So with that particular adaptation, they have exploited the canopy because it's humid enough that they can just live there permanently. They never need to come down to the ground unless for the dry season. So it's interesting that in Africa, we haven't had that same radiation of direct developers up into the canopy. This is just a break apart of that ratio that we were looking at. So the SVL against SVL and toe and the height of each species. And this is the same ordered list. As that ratio increases, the height decreases. We have one of our lovely, oh yeah, side point. I just got this paper back from review, and the reviewer said I need to remove the frogs. Oh, I think that's ridiculous. But continuing. So what did I actually find? What was the conclusion to this? Well, frogs are obviously awesome. We know that. There's a really incredible diversity of frogs at this site. And we've seen very strong patterns of vertical stratification for richness, abundance, and composition. So it's all changing and changing in different ways as we go from ground to canopy. There's a close relationship between certain traits in vertical height and reproductive mode. But what about Kermit? So if we take our study and think about Kermit's morphology, I would argue that with his very, very small toe disc width and large SVL, that would make him a ground frog. But I know that's controversial, so I'll leave that with you. In terms of future directions, have we got a bit of time? Oh, we've got a little bit of time. Yeah, it's fine. Okay, so that's what I did last year for 3 months, but I want to continue this work. So that's why I got this position at UT. I want to go back to Gabon and I want to explore how all of these kind of things interact with chytrid disease. So as we may know, BD fungus, terrible fungus that affects the permeable skin of these amphibians, prevents the gas exchange and water exchange, and has led to many declines and extinctions across the world. And we know that it's present in Gabon, although it may be an endemic lineage. We're not exactly sure at this point. We also know that BD favors cooler mountainous regions compared to the lowlands. So if we look at this threat risk map for South America, it really maps perfectly onto the distribution of elevation in the landscape. So if we think about forests, as I've just shown, the ground is a lot cooler and moister than the canopy. So in different forests, we might expect that the ground is this kind of source of BD, which might be present in the kind of in water bodies, ponds and streams and things like that. Canopy might be reasonably free of BD. So it's entirely possible that there's this differential in threat risk. In fact, there was a small study done in Puerto Rico with the coqui frog, which showed that ground-dwelling frogs had a 50% higher prevalence of BD than those found at just 2.5 meters up. So this is just a small study. I want to make this a big study because it is cool to think that there could be this very big differential in threat risk for amphibians, and this could be applied across the tropics. However, it's also going to be confusing because, like I was talking about bromeliads, they could provide a possible sink for BD. If a frog has BD and goes up into a bromeliad, that could then provide a source of BD up into the canopy because of those same microhabitats that they're using to shelter. So it's an interesting and complex relationship that I want to explore. So like I saw in Panama, we've got this differential in the wet and dry season. So if we've got frogs essentially moving down the trees in the dry season, it could be that they're going from what could be a low disease environment to a high disease environment on the ground. And if we then also think about climate change, how it's predicting essentially longer and stronger and more unpredictable dry seasons in the tropics, we might have some kind of potential perfect storm where we've got a lot of frogs being driven down to the ground. They're then in higher densities, they're then exposed to BD, they're stressed because of the climate environment that they've been exposed to. And that could be really, really detrimental to these communities across the tropics. I don't know how that's going to play out, but that's the kind of thing I want to explore. So, cool frogs. I want to repeat this study from Panama, wet season, dry season, swab those frogs for BD. And also, I'd like to do a microbiome study. So no one's ever looked at the difference in essentially what microbes inhabit the skin of these frogs from ground to canopy, which can also affect their ability to defend against pathogens like chytrid. So do the swabs for the BD, multiple species, vertical height, seasonality, profit. And that's it. Thank you very much for listening. I'd just like to say thank you to all the people that supported me and helped me along, especially the people that helped fund the actual project, all the funders on GoFundMe. And that's it. Happy to take any questions you might have. Cheers.
All right, thanks a lot, Dr. Ed Basham. Everyone, round of applause there from wherever you are. Thank you so much. That was fun. That was new, I'll say, a lot of stuff that I don't usually think about, in depth into the canopy with frogs. That was cool. Thank you. We got people here from all over the world. We got Portugal, Bangladesh, USA. We've got Cameroon, and maybe Colombia out there, and a couple other places. If I missed you, feel free to chat that in. But a good international audience. I have a few questions for you. Everyone, if you have questions for
I
Ed,
see there's a bunch
chat.
in the chat, so but please take it
Okay.
away.
Well, let me start out here since I organized this. Let me ask mine to get going. Okay, Gabon, how did you learn to ID 50 species in a new place? Because I know that's always hard for me to learn new frogs, and I don't imagine there's a really good book of the frogs of Gabon, though there may be.
There's not a good book, but there was a cool study done in the basically the few years before I went there. I have a main collaborator called Greg and another local collaborator called Abraham, and they had made a study of the species at a local national park, which was very close by. So thank God there was like a good guide for the majority of species. However, there are tons there that are like super difficult, and I've kind of just assigned them, genera species one, genera species
Yeah.
two, because they're awaiting identification. And it's highly likely that maybe two, three, maybe four of those that we found are new to science. So that's super awesome. But I didn't collect any. I didn't have the permits, and I also don't really like killing frogs. So I didn't collect any. So that means we can't describe them. But if I go
Yeah.
back, I probably
Well,
will
you had
take
mentioned
one or two.
your ID method of that some species fortunately have unique identification, and if you can even tell by eye without any kind of camera software or anything, that's even better to be able to get that personalized info.
It was super difficult, and especially with the Leptopellis genus, which they're so variable, and one species can look exactly like the other. It might be just some minute difference in their call or the ratio of the tympanum versus the eye width that it's just like it's so
Yeah.
difficult. And there's
All
there's
right.
not even good science on that. So yeah.
Okay, we've got a question. I think it's from Bill in Maryland. What statistical software did you use to create these great visualizations? So that may be two different things if you're
No, I
chuckling
used I
for
used R. I
okay.
used R. Yeah,
R, super
for
popular.
basically
Wasn't
everything.
when I did
Yeah.
my PhD, I don't remember people using R, but R is super popular these days. So if any of you are into stats, I'd say if you're looking to learn some statistical software, R seems to be the most popular these days.
Yeah, for ecologists, it's pretty well used. And then, a lot of people for bigger stuff, bigger modeling, use Python.
Okay,
But yeah.
Python used for all kinds of things, I suppose. Yeah, I used Statistica, I believe, throughout my PhD, and that was not even the most popular one. I can't remember what the popular one is, but I don't hear about it anymore. So probably come a long way in statistical software. All right, let me return. I have a few more questions. You said Greg was there. I'm not sure if he was there with you, but my question was, how did you choose your study site in the village? Because it seems like you were there by yourself, and I usually don't go to some African country just by myself without knowing anyone and just end up in a village. Like when I went to Ghana, I knew Gilbert at least the first time over email, and I met him, and then he took me around. How did you end up there, and were you by
Yeah,
yourself?
I was by myself, but I had this contact colleague Abraham who works for the kind of Institute of Agronomy and Forestry there. It's his family's village. So
Okay.
when I contacted Greg, he get me introduced me, and
Okay,
then he
yeah.
said, "Oh, you can just stay
Yeah,
at my
good.
family's village." And
All
so
right.
that's how I got there. But I was on my own, and he wasn't there. So I arrived, and I
Yeah.
had terrible French, and it was
Yeah.
pretty funny.
Okay, yeah, I didn't even maybe you mentioned that. I wasn't even thinking about what is the language in Gabon.
Yeah,
All
it's,
right, so plenty of things to deal with. Different language, not knowing many people, but at least one. And then the fact that you're in Central Africa, West Africa. So good job going there and doing all that.
I'm looking down the chat and seeing what questions we might have. Some really nice messages from people. Okay, Terry asked, "Do I put the frogs back after I found them?" Yes, I do. Yeah, all the frogs get returned to the same tree that they were found at. So, yeah, unharmed generally, nearly always. I didn't take any toe clips or anything. I just swabbed them and released them again.
All right, so Nancy asked about the different reproductive modes. Can you elaborate? I'll say that during my PhD research, that was important too. Because I was studying chytrid fungus, chytridiomycosis, and chytrid has waterborne zoospores. Different
Mm.
frogs spend different amounts of time in the water, including where do they put their young. So there are terrestrial breeders that will just put their eggs in the leaf litter and they may take off. There's plenty of poison dart frogs where the tadpoles will crawl up on the father's back and hang out there. There are frogs that put in an egg mass into the water and take off. There are glass frogs that put their eggs on the underside of a leaf and the father will hang out there to defend them. So we've got all these different ways that they can breed. What do you have to add to that? I saw you had a number at least of maybe the African amphibians or total different reproductive modes of amphibians.
Well, it really depends on the sort of like the way you classify them and how sort of like fine you make those categorizations. There was a study recently that came out with, I think it was 49 different classifications, but it comes down to really specific things. They they use a specific type of plant, or they lay their eggs in a specific way above a tree hole, things like that. So I mean, really, what you just said, it kind of covers everything. But they all kinds of things. There's crazy ones like they'll lay the eggs, and then the tadpoles will go onto the male's back, not even the female, they'll go onto the male's back, and then they form these little pockets inside the skin where the tadpole will develop in a pocket under the actual skin membrane of the male frog, and then they'll come out afterwards. And that's just one example of one of those crazy methods.
Yeah, and there were gastric brooding frogs that would swallow their young. There are frogs that
Exactly.
just keep them in the mouth buccal cavity.
Yeah.
Maybe you were referring to Pipa Pipa. I'm not sure, but Pipa Pipa, Pipa is a famous frog from maybe Suriname area,
Right.
northeastern South America, and they'll have
Yeah.
their tadpoles on their back.
Yeah. So there's so many cool, weird, and wonderful ways that they do this. And I think my favorite one is the tree hole breeders. They're just sort of what fascinate me, especially when I was in Panama. I was climbing loads and loads of trees, loads of big trees and stuff, and I, find all the kinds of species. But then I went up this one special tree, and I saw, oh, this amazing big tree frog, and it's got all this orange and green color on it. And I see one, and then I see another one, I see another one, and there's a whole group of them, and 25 meters up. And I'm starting to search around, and I see that there's a big tank of water inside a big dead branch, and they were using that specific resource. And so I saw a load of egg masses hanging on the dead wood right above the water in this tree hole. And then inside, I could see the tadpoles every now and again coming up for air and going back down. And so, that's just this amazing kind of evolved reproductive mode that has allowed them to essentially go up into the trees. But yeah.
All right, a quick announcement. Our next meeting, I put it up on savethefrogs.com/Africa, October 28th. We always do these things same time. I don't know what'll happen when we switch from daylight to whatever time, and times change in a month or so, but essentially they're going to be at more or less this time of day. Next one's October 28th. The precise time is stated on the page. And perhaps Abeje, who's here, who I have not responded to your email, but I will. Perhaps we'll have you speaking at that meeting if that fits your time. If anyone has suggestions for guest speakers, it makes my life easy if we have a guest speaker here and then we all learn something new and get different perspectives and have a bit more order in the meeting of what's going to happen, then definitely let me know. We've got Carlos out there, I think from Colombia, and let's see. Hola, ¿cómo estás, Carlos? ¿Y dónde estás?
Hi everyone, I'm in Ibagué, Colombia.
Okay, Ibagué, Tolima. Hello.
Exactly. So first and ever, sorry if my English is not the best.
It
And
sounds good.
I arrived just too late, and so I want to know how much time you take for the data. I mean, I saw in the slides that you show like dry and wet humidity. I don't know how you measure that. I don't know if you talk about the rain period or if you were talking about the ground humidity. Please tell me about this.
Sure. So in terms of the Panama dry and wet season, I think I might be able to just quickly show us. Where is it? So I measured the rain period. So I was measuring rainfall. There was actually a meteorological site really close to the forest that I was working in Panama, which is used for the Panama Canal estimation. So it's like really good. And so this was the rainfall map essentially with average data in black and then the data of the years that I was looking at. So that was just that's the dry season and everything else being the wet season. So that's how I define the seasons. But in terms of the humidity and the temperature, I essentially I use the climate data as information to inform, but I didn't use it to actually conduct any analysis. And I collected the data in the same way that I did in Panama as in Gabon. I was saying I have the temperature and humidity in a tree in the canopy, 25 meters up, and then I have another one in the understory, and then they're just logging continuously across that whole data period. So that's how I was able to collect the data from those different levels. And there's lots more different ways that I can break that up. So I just showed the average temperatures across the day, but I could also look at maximum temperatures and minimum temperatures and things like that. So I do have more data to that I could have explored, but I decided to keep it a bit more simple. Does that answer your question? I can keep going if that doesn't. Hopefully it did. But while I'm here, I was just going to say thank you to all of you that put really nice messages about the presentation. I really appreciate them. Lots of people put really nice stuff. So yeah, it's great to talk about the research and show people what I'm up to. If you've got any more questions, feel free to ask them out. And if not, no worries. And I've always got my email address is just my name. I should just put it in the chat actually.
Hi, my internet cut out. I'm back here, so I'm not sure what happened. There was a question about humidity that I assume you answered, how you measure that. Yeah, go ahead, chat in. I know you've got a website, so put in your website URL.
Oh, yeah.
You've got an Instagram, ed.basham. You can put that in there and email. And everybody out there, savethefrogs.com/Discord. I just put in that link, click the button. Get a Discord account if you don't have one. You may already have one. There's like 800 million Discord users out there in the world or some huge amount. So get on there, and we have a hashtag Africa channel. You'll see it on the left sidebar. Feel free to post anything Africa related in there or anything elsewhere in our Discord community. And let's see, I'm gonna have a recording of this. I'll put it up on YouTube and put it up probably on the savethefrogs.com/Africa page. So let's see, how do toads compare to the frogs? You found is one question. Do they have similar large pads when they climb higher? I assume mostly frogs are found in the trees. I'll just clarify in that all toads are types of frogs, and there's a huge amount of overlap when people call things, or there can be a huge amount of overlap when people call things frogs versus toads.
That's a really good question, actually, because the most arboreal frog that I found was a toad. So there was two species of Nectophrinae, which are these tiny, tiny little climbing toads. And they're both, like I was saying, the cool ones, the treehole breeders. And they didn't have expanded toe discs, but rather they had expanded kind of webbing and structures on the middles of their fingers. So I actually had them on one figure. If I can just pull out real quick, I will. And they were found consistently the highest up out of all species that I found. So yeah, depends on the species, because the big sort of like chunky toads, like the sclerophrus species, they just occurred just on the ground. Yeah, so this is the underside of that toad. So you can see that it's got this interesting foot adaptation, and this allows them to be able to climb as high up as they like, right up into the canopy, 30 meters, whatever. Yeah, so that's so yeah, it just depends on the morphology of the species.
I have another question for you.
Okay.
Can you talk to us about tree safety and where would one acquire tree climbing knowledge?
So you can get taught by professional tree arborist schools. So they exist if you wanted professional, you know, training. I actually didn't have really any knowledge. I turned up in my first field season in Madagascar when I was like 24 or something, and my supervisor, he just sort of taught me the ropes, literally, in those first, like the first week in Madagascar, and then he left and just said, "Go on." So it was pretty dangerous, to be honest. But the main things is just being just absolutely sure that you're climbing on a real branch. It's just very easy to get it over something that you think is over a big branch, and then you get up there and you realize that your weight had sort of like passed under a vine under the branch, and when you're looking up it looks like it's gone over it, and then you get up and you think, oh my god. That happened once or twice, and that's no good. So I learned from those experiences, and that hasn't happened again. um, yeah, tree safety is super important. Actually, the main danger is dislodging dead wood when you're climbing and swinging around. The rope above you might hit some kind of other branch, and then that will break, and that falls, and that could hit you on the head. So
And you always have a helmet, correct?
Always have a helmet. Yeah, always have a helmet.
Yeah.
And
right.
always have someone with me, on the ground, so that if anything happens, they can, help me out. But that's the main danger, is really getting hit by something. Yeah.
And you were out there day and night up in the trees. Is that correct?
Yeah. Yeah. And actually at night, it's really not very scary. I found it in the day, you can see everything, at 30 meters, it's like 100 feet. It's really high. Oh my God, you're just hanging on this one rope. Whereas in the day, at night, you can't see the ground. And so you just sort of feel like, it's fine.
All right. Did you ever meet Eric Lindquist in Panama?
I didn't, no.
Okay. I ran into him just randomly when I was at a place,
yeah.
and he was with a team of students climbing trees. All right. We're coming to the end of this. We have some time for more questions. We had a question: what was the high climbing toad of Gabon, Nectophryne batesii? Got chatted in there, so you can go and then see what you can find about that.
Just the species was Afra, Nectophryne afra. I also saw a question from Abeja, by try and find it again. Where is it? It's disappeared. I'm sure there was a question I missed.
I did not see it.
Oh, here we go. Oh, yeah. What was the have you seen the distance from water bodies and the tree species? So tree species I found to be not particularly important, because when I do the survey, I record if I found the frog on the tree, that I was sort of like, oh, I'm surveying a tree. But realistically, I'm surveying all the vegetation that I encounter, which can be tons of other, understory vegetation, other trees, all this kind of stuff. And the majority of the frogs that I find on those surveys occur on that extra vegetation. They actually don't occur on the tree. So I find that the actual tree species of the survey is like not important to me that much, because the frogs seem to occur on everything. But the tree is the anchor, right? So that's why it's important for me.
I have a mathematical question. I think I saw that you had a certain radius, like 5 meters, 5 meters radius or so. Was that right?
In terms of when I was climbing?
Well, you're surveying the height, but then there's also a circular area outwards from the tree. Is that right?
Yeah. So actually, when I present this kind of like the vertical surveying, that includes a 4-meter diameter circle on the ground. So that means that we are getting ground frogs, and that's roughly equal to what we can actually survey when we're up in the trees. Yeah. So you can generally swing out 2 meters that way and 2 meters that way. Yeah. So that's that equal thing. But then we also did a 10-meter radius, so 20-meter diameter circle all the way around the tree to get that to do a full ground survey. So that was the difference.
All right. And then the density number, is that frogs per the volume of air covered?
It was
your height times your
I could do that.
Squared?
It's not. I have done that, but I can't remember the numbers right now. But that's just a relative measure of the relative density. So if you had 100 frogs then you divided that by 30. But, you know, so it's just purely a
Okay.
relative arbitrary measure.
All right. All right, cool.
Yeah.
All right, we got Juan. Where are you from, Juan? Let us know. And I'll say final chance for questions, comments, if
Oh, there
anyone
was one
wants to
more from Ed
unmute
Basham about the
themselves.
distance to water
Okay.
bodies. And it was really important. So I didn't include that on this, and it's something that I'm going to do in the future because I think that's going to play a big role in terms of the seasonality, where possibly in the wet season, well, I don't know actually, but things have to go to the water bodies to go to the streams to breed, and then they might sort of go out into the terrestrial habitat to, you know, when they're not breeding. I found way more frogs near the streams and ponds than I did away from them. So it's definitely important. Whether that impacts their vertical height, that's something I'm going to look at. So I'm hoping to do that analysis. But yeah, I think it's very important.
All right, what's your future plan for? Can you clarify what's your postdoc research and what's your future plan for canopy work?
Yeah, so my postdoc is the Stengel Wire Postdoctoral Fellowship at the University of Texas. And I'm planning on going back to Gabon for dry season, wet season, just like I said at the end, swab every frog, test them all for chytrid, and see if there's a difference in sort of the prevalence of this disease across species that occur differently across vertical height. I'd also like to then repeat that all again in Colombia the year after. And so I've got like 3 major sites to do this big seasonal comparison. And that's the plan.
All right, well, contact Carlos, who's on here. He's in Tolima, and we've got a lot of Save the Frog supporters at the University of Tolima, Tolima. And also Save the Frogs longtime volunteer Biraj Shrestha from Nepal is at UT Arlington, I believe. So I suggest contact him. All right, cool.
Awesome.
Thank you so much.
Thanks everyone for listening.
Yeah, all right. I think everyone's enjoyed this as much as I have. Glad we did this. I hope to see you all October 28th. If you know someone who would be interested in attending, then bring them along, have them register, savethefrogs.com/Africa. None of you need to register again for a future meeting. Assume it'll be the same login. So you don't need to register. You should just use the same login. Put that in your calendar, October 28th. And that is it. Thank you so much. Bye.